All right, so this is number 16 from the review packet. It's one of these little shaded area problems. So let's see. Minor arc AB is 122 degrees. So this arc is 122 degrees. The radius of the circle is 10. So probably a couple good radii to draw on would be P to B and P to A, since those points seem to be important points. Find the area of the shaded region. Okay, so this angle, by the way, central angle, same as the arc that it intercepts, so that's 122 also, 122 degrees. Okay, so in order to get the shaded one, this actually goes back to the previous unit. So to get the shaded region, really what you're going to end up doing is taking the area of this whole sector. So here, I'll write it up here. So the area of the shaded is really going to be the area of the whole sector, PAB, and you're going to get rid of the triangle part of it. So I'll kind of draw a little diagram to go with it. So the shaded part down there that looks just like that is really going to be the area of the entire sector, the whole slice, minus the triangular part that's stuck inside of it, right? Okay, so in order to get the area of a sector, sector PAB, remember that's defined as your angle over 360 times pi r squared. So in this case, it's 122 over 360. So that's the percentage of the circle that we want. And we want that percentage's the percentage of the circle's area. So pi r squared goes here, which is pi 10 squared. And then if you plug that into your calculator, let's see what you get. You get about 106.465. That'd be square units or units squared, but we don't have to worry about that for now. Okay, then we need the area of the triangle PAB. So let me draw that by itself right here. So here's the triangle PAB. Oh, I did not draw where I had the pen. There we go. PAB. And we know this is 10 and this is 10, so it's isosceles, which means if we chop it with an altitude, it cuts the bottom in half, and it cuts that 122 in half as well. So we get 61 and 61. So in order to get the area of the triangle, we need 1/2 base height. So let me call the base these x's, and the height I'll call y. And we can solve for those using trig. So if I do sine of 61, that's going to be the opposite side, which is x, over the hypotenuse 10. And then I can multiply the 10 over. And then x ends up being about, when you plug that in, let me check here. Let's see, 10 sine 61 is about 8.746. And remember, the base of the triangle isn't just x, it's really 2x. So the base is about, or sorry, let me say equals 2x. And so if you double that 8.7-ish, you end up with 17.492. And I'm just so you know, I'm cutting and pasting these things in the calculator so that I can keep them more accurate as we go through the calculations. To get y, you could either do Pythag at this point, or you could do cos. Cosine of 61 is going to be y over 10. So then 10 cos 61 will be y. And so then y ends up being about 4.848. So I'll tack these onto the picture here. This whole thing is about 17.492. And this part right here ended up being 4.848. Okay, so then the area of the triangle, PAB, is going to be 1/2 the base, which was 17.492, times the height, which was 4.848. And if you cut and paste those values from the calculator, then you end up with about 42.402. Okay, So then the last step now, so the area of the whole thing was the 106. The area of just this part, the triangle, was 42. So if we subtract them, we get the area of this originally shaded region there. So let me Google that. So the area of the shaded region is going to be the sector, 106.465, minus the triangle, 42.402. And if you cut and paste stuff from the calculator, you end up with 64.063 once you round it. So that's what goes here. If you wanted to include units, the original problem just said units, so the area would be square units or units squared. Okay, so let's take a look at B. B says, find the probability that if you choose a point randomly from inside that circle, it will be in this shaded region that we figured out earlier. Okay, so remember probability, in this case of getting a point in the shaded region, it always turns out to be, it's the area of whatever you're hoping the point is in. So in this case, it's the shaded region. So it's the shaded area over the total area, wherever you're picking your point from in the first place. So total area, which in this case is a circle. So the shaded area we figured out in this part. So that's the 64.063. The total area is the area of a circle with the radius of 10. So the area of the circle is pi 10 squared. Now, when you plug this into your calculator, you got to be a little bit careful. So I'll show you here what a common mistake is. So a lot of students, a lot of students end up running the 64.063 divided by pi 10 squared. If you think about pi 10 squared, that ends up being about 300. So 64 divided by 300 should be a pretty small number. But if you type this in, you end up with a huge number, and that doesn't make sense for a probability. And the reason it's doing that is if you don't use parentheses for the pi 10 squared, it's taking 64 divided by pi, getting an answer for that, and then multiplying the whole thing by 100. So what you really need to do is use parentheses around the denominator to make sure that it knows the whole thing down there is below the 64. So it's about 20392. So this ends up being about 0.20392, which I think you get even if you cut and paste the long decimal from before. Or you could say 20.392% if you prefer the percent version. So either of these is okay. So it's either 0.20392 or 20.392%. If you just did the decimal version, you could just say 0.204 instead. So that would be rounded correctly. Okay, I hope that helps a little bit, and I'll see you guys soon.